Hello everyone, this is a current measurement device. I am having a second modification and a second video on this topic. So as you can see here, the count is very stable now. In the previous video you have seen the count was not very stable. So in this video you can see the count is very stable. You can see the count is not changing, 729, 731, it is stable, and the milliamps is also very stable. You can see. So this is an upgrade in this design. So I have used a low pass filter as an upgrade after the envelope detector. So that's why the low pass filter is filtering out all the harmonics and the output is very stable. The input to the input signal to the Arduino Uno is very stable. You can see here the count is very stable. So now I am going to show you the circuit. So here you can see this is the current transformer. This blue device, this is the current transformer, and this current transformer is in series with a load lamp. So as you can see here, this is a load lamp, and the load lamp input voltage and current is controlled with this variac. You can see this is the variac. So this variac is basically controlling the input voltage and input current to the load lamp. So when we are changing the variac, the current in the circuit, primary of the current transformer is changing. As a result, the secondary of the current transformer also changes. The secondary of the current transformer is fed to this amplifier portion. You can see LM324 is under. Here there is LM324 amplifier, and here is the Schottky rectifier, and here is the envelope detector. This capacitor and this 100k resistor, they form the envelope detector. So now you can see here, this is the new incorporation of in this video, this 100 ohm resistor and two 10 microfarad capacitors in parallel, 20 microfarad and 100 ohm resistance. I am making a low pass filter. I am filtering out all the high frequency signals. The center frequency of this filter is 5 kilohertz. So more than 5 kilohertz, none of the frequency will be allowed to pass through. So actually it is much less. It is somewhat like 3 kilohertz, 2.5 to 3 kilohertz. It starts to act. So this is the low pass filter. The output of the low pass filter is measured in multimeter. You can see here, this is measured in multimeter. You can see this is measured in multimeter. So this is the current reading of the primary of the current transformer. The 1:1 current transformer primary is reading now 500 milliamps. As you can see, the primary of the current transformer is reading 500 milliamps. Now I am going to show you the circuit. So as you can see, this is the circuit. So the circuit is having one variac, 220 volts 50 hertz. There is a variac. I have shown the variac. I will show it again. So this is the variac, and this is the load lamp. So here this is the variac, and here is the load lamp. Here is the 1:1 CT. Here this is the 1:1 CT. The secondary of the 1:1 CT is connected to LM324 operational amplifier. You can see here the gain of the operational amplifier is 4.7. 4.7k divided by 1k is 4.7. So there will be an amplification of 4.7. The voltage here will be amplified 4.7 times. It will reach here, and this is a buffer. This is a buffer so that the required current can be supplied. So this portion should not get overloaded. That's why I have used this buffer. After the buffer, there is a rectifier. This is a Schottky rectifier with a 1 microfarad capacitor and a 100k resistor in parallel. So this is an envelope detector circuit. These two, this capacitor and this resistor, so they are forming an envelope detector. So after the envelope detector, I am using a low pass filter. So I don't want to show the high frequencies to the Arduino Uno. The Arduino Uno was getting confused in the previous video. It was not able to show the counts. So now I have used a low pass filter. I am filtering out all the unnecessary noisy signals, and I am giving a pure signal to the Arduino Uno, and it is displayed to the LCD. You can see is displayed to the LCD. Now I am going to show you my results. So as you can see here, these are my results. You can see with the increase in voltage, with the increase in current, this is the Arduino milliamps. So here you can see there is a deviation of the Arduino reading and the physical milliamps. See 402, I am reading 480 on the Arduino scale. You can see I am reading more. So 502, I am reading 588. 602, I am reading 703. And on the low range, 200, I am reading 229. 100, I am reading 109, 108, 109. So at very low range, it is okay. And then slowly it is deviating. There is a deviation. It is not linear. The Arduino Uno output is not linear. It is not matching with this reading. This is because of this envelope detector network. This capacitor is getting charged, and it is not maintaining the linearity. It is not maintaining the linearity because the charging profile of a capacitor is not linear. Up to 80% it will be somewhat it will be linear. Still it is not linear. It will be like it is like a humpy structure, and after that it will saturate. So here you can see this capacitor. I conclude this capacitor is not making the circuit linear. So what I am proposing in the next video, I am going to divide this line, this curve I am going to approximate. This curve I am going to make an approximation to this straight line. So whenever there is a turn, I will approximate it with this straight line. So like that I will try to rectify the deviation. So that will be the next part of the video. So this is all for now. Thanks a lot. Thanks for watching.